All right, take a look at your homework answers. I think I might have a few of you I didn't get earlier. Let me check those. Kelsey, you're right there. We need that Look at this.
Yeah.
Adam, Adam.
I submitted this morning.
Yeah. I submitted mine this morning too.
Yeah,
What time this morning? I mean,
around 8 o'clock.
Second period. 7 a.m. 7? My house comes in right like I'm at school.
Yeah, I was submitting mine when I did review.
So it happens like I get right away. I try to manage.
It's really not.
I'll work in on
it.
Yeah.
My bad.
Seriously.
Okay, let me see what you got there.
Okay. Just turn your homework in.
Dude, I turned it in second period.
Late grade, minus 2 full.
Who do you get, who copy off?
Copy up. It's all straight from the dome.
Right there?
Yeah.
It's all up there.
All up there.
Up there. Thomas, need yours. Kelsey, need yours. That's right.
Yeah. What?
And Thomas.
If you're hydrating, you're drinking. Did I say hydrating? I said rehydrating. Rehydrating.
What's that say?
What has to do with
I'm replenishing my
body.
Yeah.
Well,
hydrated.
You're not drinking that right now.
Alright, what's going away? Adrian, we good? Yeah, those are who you text. What you got going on? What you got going on there?
Yeah.
Yeah, just take the shirt off right off there.
Okay, Ian.
All right, make sure on number 7 or 24, what is that, 7? How does that start? 7 square root of 3? Times 49 square root of 12. So for this one here, let me do it over here. So for 24, so if I got 7 square root of 3 times 49 square root of 12. All right, what are you thinking on that one? Jackson, how did I get this answer? You got it wrong.
How you take the 49 and turn it into 7 squared.
Okay, 49 is 7 squared. Square root of 12. Okay, what'd you do? Any other ideas? Elizabeth?
What is the square root of 12 with 2 square root of 3?
Square root of 12 is 2 square root of 3, because they gotta have this same radicans are the same insides. So that is correct. So that is now 7 squared to the 2 square root of 3. Multiply those together, and that becomes 7 times 4 radical 3. And now you add those, and that's where we get the 5 from. 1 plus 4 gives me 5. So it should be 7 and then 5 square root of 3. All right, for that. 56, you should draw in that asymptote if it's not at 0. So I know we didn't draw in them yesterday, but when that moves, just to kind of indicate where that horizontal asymptote is, y equals -2, domain negative infinity to infinity, range negative infinity to -2. Okay, for those. Any other questions on those? Elizabeth?
Can you go through 26?
26. Well, you can also write that as 1 over 3 square root of 5.
Okay, then I was right, never mind.
As well. Okay, because I know a lot of people, I know we do emphasize we got a negative exponent to make it positive. So that is equivalent for that one. Mason, same question?
Yeah.
Okay, anything else, Thomas?
Can you go through that one?
All right, what is the original 26? What does it look like originally?
9 square root of 5 divided by 27 square root of 5.
Okay, 9 is 3 squared. 27 is 3 cubed. And so this becomes 3.
Yeah.
Okay, 2 square root of 5, and then 3 to the 3 square root of 5. And then 2 minus 3 gives me the negative square root of 5, which is equivalent to 1 over 3 square root of 5. Okay, for that one. Okay. Anything else? Nope. Nope. Okay. All right, let's see. Sierra, would you explain to everybody what an actuary is?
Isn't that like someone who does like interest or something?
Someone who does what?
Like interest for like the banks or something?
So they just got a guy that sits in the bank and he does the
Or
interest.
like he counts.
Counts the money?
Yeah.
He's the money counter. No.
With insurance and interest.
All right, so you kind of got an idea.
Banks.
Tyson, you know anything about actuaries?
Oh,
He got no clues.
I'll know, can I phone a friend?
No.
Actually,
No, your friends don't usually come up.
Okay.
Riley, you know anything about actuaries? No? You probably want to know, don't you?
Yeah.
Okay, well, good. Since you want to know, I'll see if I can help inform you about what an actuary is. Well, if you really love maths and want a rewarding career where you can make a difference, then the actuarial profession is for you. Okay, it is for you. So Sarah, you were kind of right. You kind of had the idea a little bit. Actuaries are problem solvers and strategic thinkers. Okay, well, that eliminates a few, but not everybody, who use their mathematical skills to help measure the probability and risk of future events. They use these skills to predict the financial impact of these events on a business and their clients. So I had a little video made here for you.
An actuary tries to.
Well, I got guide notes to give you.
And that's a really difficult thing to do. And the only way that people have come up with so far is to look
The kind of technical answer is we use it
A little
to
British.
kind of like help manage and measure risk. But I think what we actually do is explain things that are really complicated to people and try and make it as simple as possible.
So it uses data, analyzes the past experience, and predicts the future based on judgment, based on what's currently happening in the economy, the situation.
Actuaries are needed where there's something that can't be measured or counted. So for an insurance company, how much money does an insurance company have to set aside to be able to pay out to policyholders if something happens, or how much money does a pension scheme need to put aside to be able to pay benefits out to its members. I think the key thing in actually is being able to look at that number and say, is that number right? And actually apply judgment and expertise and wider knowledge to help make it the right number.
While actuaries are great at the technical stuff, they are also great communicators.
It's not just about spreadsheets, it's about lots of interaction. And actually, every single day you're doing things, and it also keeps it interesting. If you're just a guy just behind the computer, just doing lots of number functions, you're actually not adding too much value because if people don't understand what you're saying, then you can do the most complex math, but no one will really care.
Insurance fundamentally is about helping people to protect themselves, sharing out the risk. And an actuary's role is to make sure that that risk is correct.
They think actuaries in general are important to society because of what they do in terms of everyone's lives, which is pensions, your car insurance, your life insurance. These are things that affect everyone.
Wonderful video.
Thank you.
Now
All right.
I want to be an actuary.
You want to be
So
one?
bad.
I know. Well, you know, a lot of times like those people really wanted to be math teachers and they couldn't quite cut it.
Right.
So then they went to the actuary field.
So you're better than actuaries.
Basically, yeah.
Wonderful.
Basically, yeah. All right. So actuaries, it's a lot of people don't know about it, but it is it's a job that if you're good at math, it might interest you. Main thing is like insurance companies. That is probably the main source of where they're employed. But there's other situations where actuaries are employed. Goes through where they are. The following list of actuarial projects. All right, analyzing insurance rates such as cars, homes, or life insurance. All right, do you think you pay the same car insurance I pay?
No.
No.
Depends.
Depends. It does depend. But typically, 16-year-old boys and girls and 17-year-old boys and girls are young and reckless and are a higher risk than older, more mature men. Okay, so you have a higher car insurance. Okay, home life insurance. So how are those rates set? Okay, they just don't like randomly pick a number and say, let's do $20 a month. No, they do some research. Corporate planning, calculating the fair price for a new insurance product, forecasting the potential impact of catastrophes. Large insurance companies, hurricane comes through, they have to pay out millions, if not billions of dollars. They have to have it. Analyzing investment programs. I'm part of what's called the STRS, State Teachers Retirement System. So one day when I retire, I'm supposed to get a yearly income based upon what I've put in. So they make adjustments at times. So they might say, all right, we need to make more, you need to pay more per month or per year to fund the retirement system. Or the benefits might be altered. So instead of doing a 15% copay, maybe you do a 20% copay because of the amount of money that's in the system. So there's a lot that they do. There's actually a major actuarial sciences that several schools have, not every school, but there are several schools that have them. But it's just something that you might be interested in that you might not know about, because we're going to deal with money today. So that was a good intro. Plus, supposedly or allegedly, they do make a pretty good wage. Not quite what a teacher makes, but probably pretty good.
Nice.
Yeah, nice.
That's very rare.
Why weren't you one?
Because I'm a teacher.
You wanted that big bank.
Yeah, I mean, I didn't want to settle.
Yeah.
I didn't want to settle. So
That's too late for you?
basically.
Smart.
All right, simple interest. Compound interest is your friend. This is probably the most relevant lesson we will do all year of you and later in life. This is something that will affect you more than likely the majority of your lifetime. Interest. There's good interest and bad interest. What's bad interest? Credit card interest. Mortgages have interest. Car loans have interest. All that interest goes to the bank. If you could pay for your house with cash, then you would save thousands and thousands of dollars. But most people don't have that money laying around. Good interest is money that you put in the bank and they pay you interest. Okay, so let's just take a look here. Simple interest, principal times rate times time. So under this situation, the simple interest would be 5,000 times 4% times 3 years. Go ahead and see what that's going to give us. Get your calculators out. Make it work. All four of us done. What about that? All right, what do we get? Nathan, what do you get?
I didn't get anything.
You got a calculator?
Yeah.
Oh, you even got a calculator. All right, that's half the problem there. All right, multiply it in, see what you get.
6,000.
Well, let's knock a zero off of that. Yeah, that's an awful lot of interest. Let's go 600.
Multiplied by 0.4.
0.4. Well, I would like that interest rate.
Yeah.
Okay. Yeah, so that's not 40%. It's a little excessive. But 0.04, $600. All right, now here's how compound interest works. You don't have to wait till the end of the 3 years to take the interest. You can take it at any interval you want. So let's take it every year. And then you take that interest and you put it into your account. And so let's see how that affects it. So after 1 year, we're going to calculate the interest. So it's going to be 5,000 times 0.04 times 1. Okay, 5,000 times 0.04 times 1, because we're only doing it for 1 year. And then when you multiply that out, you should get $200. Now you take that amount and you put it into your account. So now you have a total of 5,200. Now we want to see how much we have at the end of 3 years. You keep it in there. At the end of the 2nd year, you take the interest again. So after 2 years, interest will equal 5,000 times not 5,000, because we now have 5,200. 5,200 times 0.04 times 1. All right, how much interest is that going to be? 5,200 times 0.04 times 1. Esther, what do we get?
208.
208. 208. And so now we have 5,408. So now after the 3rd year, after 3 years, interest equals 5,408 is the amount we have in the account times 0.04 times 1. And now, what do we get for that one? Audrey, do you have it?
216.32.
216.32. 216.32. So at the end, I get $5,624.32. Simple interest gives me just a straight 600 because we wait to the end of the 3 years, you calculate it, 600. If we do compound interest, we take interest, we add it into the account, we end up with more, 5,624. Okay. Now the longer you take it or the different interest rates, then the more money there will be. So compound interest is a good thing. Okay, it is a good thing. All right, here is your compound interest formula. A equals P, parentheses, 1 plus R over N to the N times T power. All right, that is the formula. You're pretty familiar with most of it. N is probably the one you're least familiar with. That is the number of times per year interest is compounded. Okay. So for example, if it's compounded quarterly, that means N is 4 times a year. Okay, every 3 months you compound the interest. If it's compounded monthly, then N is 12. Okay, for those. And then there's a lot of different scenarios, but that's the case. One thing is, if it's compounded daily, that is always 365. Don't think, oh, it's a leap year or 365 and a quarter. Just, it is 365. So if it is compounded daily, we use 365, okay, for that. All right, let's take a look at a case here. For the accumulated value of find the accumulated value of an investment of $2,000 for 10 years at an interest rate of 7% if the money is compounded quarterly or monthly. So we want to take a look at the differences. So for quarterly, N is 4. For monthly, N is 12. The only thing you got to be careful is how you enter your calculator. Do not round anything off until the very end. Okay, do not round anything off till the very end. So in this case here, A equals P times 1 plus R over N to the N times T. So the final amount, the principal is 2,000. 1 plus 7% divided by N, which is 4, to the 4 times 10 power, which would be 40. All right, go ahead, see what you get. Kylie, let me know what you get.
I got 4,003.19.
All right, $4,003.19. I agree with that. Double check and make sure you got that. Now, here's what I said. The only thing you got to watch is how you enter. Now, this is typically one of the older models. And if I do 1 plus 0.07 divided by 4, okay, here's what you got to watch. Okay, if yours automatically pops up with that exponent up there, you're fine. But if I put in 4 times 10 as it is, it gives me, oh, what did I do wrong? Oh, I know what I did wrong. Let me clear that all out. 2,000 times 1 plus 0.07 divided by 4. Okay, if I do to the 4 times 10 power, okay, it gives me 21,437. That is not right. Because you have to, in this case, either put the power 4 times 10 in parentheses or multiply it out. So if I, instead of 4 times 10, if I just make that 40, then it will give me the right answer. So just be careful on that. Now, if it gives you that little power already, then you don't have to worry about anything. All right, the second case, compounded monthly. A equals 2,000. 1 plus, holy cow, what now?
Hello, sorry to interrupt. Do you have this student?
No, she's being quarantined.
Okay, well, good to know. Thank you very
Yep.
much. Sorry to interrupt.
All right. 1 plus 0.07 divided by 12 to the 12 times 10 power. Mason, you got that answer?
Plug it in.
Oh.
$4,019.32.
4,019 and 32 cents. All right, it's better. The more times you compound, the better. Okay, it will add up. So in this case here, it's a little bit more than $16 more, but if you can do it compounded more, it's better. Now there's a balance, so is it better to have a better interest rate or more compounding? So in this case here, you've got $25,000 to invest for 3 years, 10% compounded monthly or 8.25% compounded daily. Daily is going to be 365. So 10% compounded monthly is N is 12, 8.25% compounded daily N is 365. All right, go ahead and figure out what you're going to get for those two. Make sure that 10% is 0.10 and 8.25% is 0.0825. So I want to know the actual values. I'll write down the formula here. I think it was 25,000. All right, so we want to take into account, or we want to see the effect of changing the interest rate and then also changing the number of compoundings. We do want a higher interest rate, okay, if it's money in the bank that is gathering interest for us. You want a lower interest rate if it's on a loan or a mortgage or a credit card. That's interest you're paying to the bank or you're paying to someone.
You did 25.
Yeah, I did it right now.
Both times. Yeah, we 12 times, 12 times. Multiply those.
Oh.
That's a dot. Multiply those.
Maggie, you got a book?
Yeah.
What'd you get for the first one, Maggie?
33,704.55
59 cents?
or 55.
55 cents? I think that's right. We agree? Okay, 33,704. All right, now we lower the interest rate a little bit, but we up the compoundings. Okay. Kaden, what do you got for the second one?
I said $32,019.59.
Okay, that is, I do believe correct. Make sure we double check that. All right, so even though the number of compoundings increased, the drop in the interest rate was more, had more of a factor on that, so you got less in that case there. So all things being equal, interest rate is probably going to dominate a little bit more than the number of compoundings. That's why if you've ever noticed, if you ever had your parents refinance their house, that means that whatever interest rate they originally got their mortgage at, let's say the interest rates drop, then they refinance and you can save money on your monthly payments for those. All right, now this next one here. Now in 2000, the median price of a house in Hartville was $128,000. If the value of houses is increasing at a rate of 4.5% per year, what can we expect the price to be in 2012? Okay. One thing about houses is they typically appreciate in value. Okay, they typically go up. Not always, but that is typically, historically they do. That's why people flip houses. That's why people invest in real estate, because real estate typically goes up. Now, this is a little bit different. It doesn't say compound interest. It doesn't say it's compounded monthly or quarterly, but we can still use the same concepts. Now, if it is, they tell us that it goes up at 4.5% per year. It's really compounded, but how many times a year? Really only one time a year. So this means that our N is 1. It's the same situation, it's the same scenario, and we can use the same formula, except N is 1. But look what happens to our formula when N is 1, okay? what's that going to turn into when I plug in a value of 1 for n? It becomes 1 plus just a r, because r over 1 is r, and then 1 times t is t. So that's what's going to happen when n is 1. Everything else is going to be the same. It's going to model a compound interest problem. All right, so plug in 128,000 for P, bless you. And then 1 plus 0.045 to the 12th power, because we're doing for 12 years, from 2000 to 2012. All right, see what you come up with. Try to make a mental guess. Alex, let me know what you get.
I got $217,072.82.
That's what I want to hear. So in 12 years, it gained value of $90,000. Okay, so if you sell it, you made a $90,000 profit over a 12-year period. Again, that is why a lot of people will invest in real estate, or why your house is a major investment for you, because it typically gains in value. All right, some things that lose in value are cars. Okay, typically, and then people will tell you this all the time, when you buy a new car, as soon as you drive it off the lot, it's going to be worth less than you paid for it. Okay, that's typically an adage. With the exception of classic cars. Classic cars and certain car collectors can appreciate value, but typically you go buy a car, you drive it, it's going to be worth less. Okay. All right, now how does this work? It's 9% per year, so it's similar to what we did. N is 1, but it's going to be 1 minus r to the t. You're just going to subtract your interest rate or the depreciation rate from 1 instead of adding to it. Everything else will be the same. So now A equals, my principal is 15,000. 1 minus 0.09 to the 5th power. Adam, let me know what you get.
$936.05.
All right, I'm going to advise you not to go into the banking industry. Okay, just I don't think I would go into that yet. Okay, a little bit of more work. So you hit something wrong. Did you put 0.9 in?
No.
No? No. Okay, that's all right.
I did 1,500.
1,500. Okay. Well, that's it. All right, so then just change it. So it's going to be 9,000. And what else?
$360.48.
All right. Do we agree?
Mm-hmm.
All right, we got it. All right, 9,000. 900, that would be a heck of a depreciation. But that's okay. So as soon as you drive a car off a lot, it's typically going to be worth something a little bit less. And it's going to depreciate over time. And you're never going to, you buy a car for $30,000, you don't sell it for that. It's always for less. All right, last example here we're going to cover. Grandma, we love grandma. Grandma wants to give you $50,000 for college. That might take care of your first year. Depending on where you're going. When you turn 18, so she's going to hand you over a big lump sum of money. How much would she have needed to invest when you were born if she's getting 8% interest compounded quarterly? All right, once you see that compounded quarterly, okay, that means we have to use that compound interest formula. In this case, N is 4, so we have to take into account N. But now in this case here, we're not solving for A, we're actually given A. A is $50,000. We need to figure out what P is. We need to find out the initial amount she needed to start with in order to get $50,000 at the end. So we're gonna go backwards here a little bit. So 50,000 equals P 1 plus 0.08 divided by N, whoops, N is 4, to the 4 times 18 power. Do not, as I said earlier, do not round off to the very end. You can type that all in at once, and there's different ways you can go about it. But in the end, basically, we need to take $50,000 divided by 1 plus 0.08 divided by 4 to the 4 times 18 power. That's going to be the principal. You can do the denominator first, and I'm going to do this. I'm going to take 1 plus 0.08 divided by 4 to the 4 times 18, which is 72. Okay, don't round that off. Now we want to take 50,000 divided by that. So remember, you can take 50,000. I assume everybody knows this, but I guess I shouldn't. If I want to use that value without typing the whole thing in, remember you can hit second and then that right above the negative answer, and it uses that answer there. And then it gives me $12,015.94. So basically, if you started with around $12,000, you should probably have around $50,000 when you're done. So principal equals 12,015.94. Okay, for that. All right, this is something that, quite honestly, comes up every day out there. Okay. Dealing with finances, dealing with investments, dealing with appreciation, dealing with depreciation, all that good stuff. Your 401k, you know what the value of it is.